those unique men and women who are contributing to the fight against climate change, and I hope it will help you to take a step in this formidable movement. So before we start, I just want to share a few words about us, as this podcast is just the tip of the iceberg of what we do at Startup Basecamp to support the climate tech movement. Our mission is to accelerate capital deployment towards climate tech founders, allowing them to focus on scaling their solutions. How do we do that? Every day, we help founders access to resources and connection and gain the visibility they need to expand their growth. We do this in a number of ways with a membership platform, a Slack group with a growing number of founders, investors, and experts from around the world. And recently, we went one step further with the matching services to connect founders with top climate tech investors. Keep in mind that we are able to do all of this thanks to the support of our listeners and our members. So please like and subscribe, share one episode with a friend, join a community, and if you haven't already done so, make a small donation to support our work. It really means the world to us. And now, enjoy the show!
In this latest episode of our Founder Series, I invite you to join me in a dynamic roundtable discussion with the visionary leaders shaping the future of sustainable technologies. We continue our journey with Cleantech Open Northeast Senior Director Beth Zonis and meet 4 emerging finalists from the 2023 to 2024 season. This marks our 4th encounter showcasing the incredible ecosystem that Cleantech Open cultivates. An environment where the most promising minds tackle critical issues in energy, manufacturing, and resource efficiency. The new cohort brings fresh perspectives, proven research track records, and cutting-edge industrial partnerships. In this session, you'll hear directly from them. Gianluca Roscioli, founder of Arculus Solutions, enabling hydrogen transport in existing natural gas pipelines through an MIT-developed hydrogen barrier coating. Airjav Shah, founder of Hydrogel, using novel polymeric resins for more efficient, cost-effective industrial purification processes in food, pharma, and biotech. Marissa Beatty, co-founder of Turnover Labs, converting mixed CO2 emissions into valuable chemical building blocks, creating a circular process that reduces waste and emissions. Jeff Maelstrom, founder of Greenspear, transforming CO2 into high-quality graphite for EV batteries and energy storage, strengthening domestic supply chains and reducing carbon footprints. Listen in to learn about their work, find inspiration, and discover how to get involved in shaping our cleaner future.
Hi everyone, welcome to the Tech for Climate podcast, episode 99. So very excited to have you all here today. Today is going to be a special episode, as we do often with, and I think it's already the 3rd year that we're collaborating with the Cleantech Open Northeast chapters and Beth here. The format's slightly different. It's going to be a quick pitch format, where we're going to have like the chance to have like 4 amazing companies that are finalists of the Cleantech Open Northeast chapters, who will present their company. And to start off, we'll start with Beth Zonis, sorry about the pronunciation of your name, Beth, who's a senior program director for since a long time now. I don't know how many years, Beth, you've been working with the Cleantech Open Northeast chapter, but since a long time, no?
Yeah, I started in 2017 in this role and had been working with the organization and programs since 2009 as a volunteer. So I've been very involved with this group for quite a while.
Yeah. So, but I think before we start, I'd love to hear a 30-second intro, if it's still necessary for the audience to know more about you guys and what you do. Can you tell us a bit more about the Cleantech Open and the Northeast chapter that you have been working with?
Yes, of course. And first of all, I want to say thank you to Guillaume. It's really exciting to be here and to introduce the 4 superstars of the 2024 Cleantech Open Northeast cohort. And just so you all know, they include the National Grand Prize winner, the National Grand Prize runner-up, the National and Northeast People's Choice winners, and the winners of the Agriculture, Food, Land Use Prize and the Carbon Sequestration CCUS prize. All 4 of them are Northeast regional winners. And that's pretty significant when you think that, when you realize that there were 42 graduating teams in the Northeast and 92 graduating teams across the entire program. So you asked about Cleantech Open. So Cleantech Open is the world's oldest and largest accelerator for clean tech startups. I run the Northeast region, spans from Eastern Canada to Virginia. The accelerator is run in the Northeast by ACT, which is the Alliance for Climate Transition. And ACT leads the just and equitable transition to a clean energy future and a diverse climate economy. So just very briefly, the accelerator is like a mini MBA with expert mentoring, lots of professional networking and connections. We run for 5.5 months each year from the end of May to the end of October. And the startups learn a lot, really about the basics of how to put together a business plan, things like customer discovery, marketing strategy, financial modeling, and they have some very clean tech specific assignments, such as creating their sustainability plans and calculating their greenhouse gas emissions reduction potential. The materials they create are designed to help them run the business and also be the starting point for data rooms so that they can share those with future investors. And
Fantastic.
lots of connections, as I said. Yeah.
So who should come to apply to the Cleantech Open?
So that's a
Oh.
great question. So we accept startups who qualify as clean tech, and we define clean tech as really any topic that or solution that can benefit the environment. And that could be hardware, software, services, or some combination. And many of the startups have tough tech, which you'll see from the group today. And yeah, they need to have some kind of plan, something a little bit that they've started usually in a lab, and they should not have raised more than $2 million in equity funding when they apply. And then we work with them to, again, help them build those connections and the materials to propel them forward. We connect them. I meant to say earlier, we connect them each with 4 mentors who serve as an advisory board to them too. So these startups need to have 2 team members, and they need to really be ready to work with all of these volunteers who are very eager to help propel their businesses forward.
In terms of selection of those companies, so we understand like on the more I would say the structure part of it, but in terms of like the technology that they're developing, you mentioned software, hardware. In terms of impact, you guys also looked at a certain type of impact in terms of GHG emission that would be a bit, or like how I would say like how the different service or technology that is developed by those companies have an impact on the natural environment, for instance, or maybe on optimizing like process and logistics. What is the impact threshold that you guys have in place, and that are kind of like this baseline to qualify to join the Cleantech Open program?
Well, typically, Guillaume, the startups don't necessarily have their calculations set before they meet us. So it's, when they apply, they don't necessarily have that information yet. So we work with them to help them determine what are the things that they're going to make a difference on. And we do not necessarily judge them up front on how much of an impact we think that they'll make. But the startups that end up on the winners podium as the ones you're seeing here are the ones that are definitely going, we believe, are going to make the biggest impact. So collectively as a cohort, the startups have actually calculated their emissions reduction potential this year at 1.39 billion metric tons of CO2 equivalent per year. That is equivalent to taking 303 million gas-powered cars off the road each year. That's a lot of CO2 reduced. Now that's when they're at scale, so this is a future prediction. But that's a really great number to be able to say they should have a big impact. And we just need to give them all the chances that we possibly can to get in market and to thrive.
Any success stories or few examples of companies that came early on with you guys in the different batch and now have reached a different stage or level, or in terms of like eventually IPO'd or got acquired or raise a significant amount of money or have a tremendous impact? Do you have like any success stories that you would like to share with the audience today?
Yes, we do have a few that are worth mentioning. So I like mentioning a few that maybe some of you have heard of. So this is not in any particular order, but some of you may have heard of Spark Charge, which is a company based in the Boston area that started out making electric vehicle chargers that were really on demand. So you run out of charge somewhere on the road, you could call Spark Charge and say, "Come, give me a charge." They now are building and implementing fast charging systems. So they're being implemented across the country and they're doing quite well with that. Another one is Block Power, which has a really interesting story about environmental equity. And they've grown to be pretty large. They're working in the HVAC space and they're based in New York, and they also have some national reach. There's let's see, there are some other very different kinds of companies. There's a company called Divert, which is doing waste management, and they're in Massachusetts. There's a company in Rhode Island called Flux Marine, which is developing, or actually they have developed an electric outboard motor for boats, which is really fun. There's just a lot of different kinds of things. There's a company called Osmosis, which we're keeping our eye on. They are not yet in market, but doing gas separations. And that one I think will do quite well also. Many of you may have heard of Bevy, which is a company that makes systems for dispensing water, which reduces water bottles. So lots of different kinds of solutions are coming through the program.
Fantastic.
And then there are the ones that get to me today. Oh, and I would also mention Princeton New Energy, which is doing quite well. They're out of New Jersey, and they have a solution for recycling lithium-ion batteries, and they've just set up a new facility in I believe in South Carolina, if I'm not mistaken. And yeah, and there are quite a few others doing flexible solar and plastic, working with plastic to develop biodegradable versions of plastic. Lots of different things happening. It's a really exciting.
Super exciting. I mean, there's so many areas to be decarbonized, and so many problems and subsector and categories where change is more than needed. So that's very exciting that you guys are able to support such a large panel of companies. So maybe just to conclude here, when is the next batch starting, and when are you opening the application?
Oh, great question. So we will start up again in our applications will be due in April of 2025 for the 2025 cohort. We'll be recruiting with live in-person events around the region and across the country in the first part of the year, so in Q1. So look out for that. You can go to cleantechopen.org and find that. You can also look up our my employer, which is ACT, and you can find them at joinact.org, and you'll see the many things that we do there. And I just want to point out something else that that I think is really interesting about this year's cohort. It looks like, I believe all of them are involved in chemistry, which is a bit unique, I believe, for this cohort. And I just thought it was really interesting to see what everybody is working on. And just to give you a quick synopsis, we have Arculus doing hydrogen barrier coating for natural gas, for retrofitting natural gas transmission pipelines, Hydrogel doing industrial separations for purification of fermentation products for food and pharmaceutical industries, Turnover Labs with CO2 electrolyzers to convert mixed emissions from chemicals manufacturing into basic chemical building blocks, and GreenSpear, which is transforming sustainably sourced CO2 into graphite for the EV battery and grid storage space. So 2 of them are doing carbon utilization, which is really interesting. And one is involved with hydrogen and the other involved with purification and separation. Really interesting that they're all into chemistry. And what we found in the past, and we haven't done our analysis yet this year, but we have found in the past that the chemistry related companies tend to be among the most successful. So we'll see if that holds true for this cohort as well.
Okay, but fantastic. Thank you so much for covering and already unveiling a little bit of the different founders that we have here. So we're going to start with you, Arjav, from Hydrogel. So you probably know the format that I mentioned to you guys before starting the show. If you could maybe give to the audience a 30-second introduction about Hydrogel. Tell us a bit more about what is the problem that you guys are trying to tackle and to solve here, and for who.
Absolutely happy to do that. And thank you for having me, or it's a pleasure. My name is Arjav. I'm the CEO and co-founder at Hydrogel, where we are trying to make industrial purifications more cost-effective and sustainable. So the analogy I like to give is sieving pasta. Like we've all strained boiled pasta at some point. But imagine if you lost 50% of that boiled pasta while straining, and if you could only use that strainer once, that would be tragic, right? Hopefully that doesn't happen to any of our pasta, but that's an unfortunate reality for a lot of industrial purifications today, particularly in the food, protein, amino acid, as well as biopharmaceutical purifications, where a lot of valuable product is lost to the purification steps. And of course, there's a lot of concerns associated with sustainability of these processes. So at Hydrogel, we're hoping to make those purifications, particularly in the food and biopharmaceutical space, more effective, reduce the costs associated with manufacturing and purification, and significantly reduce the carbon footprint associated with these processes.
So maybe can you remind or explain to the audience a little bit, why did you start the company? What was this the why behind you? Who is your how is your team composed as of today? What gives you this exceptional thrill and fire to build Hydrogel and to tackle that problem? I mean, tell us a bit more about this little beginning of the journey and how you came out with this unique solution.
Absolutely. So I grew up in India, and I grew up in the heart of India's chemical manufacturing industrial belt, the largest one indeed. And growing up, I saw these adverse effects of booming industries that I grew up around, not only on our water, but also our food and surrounding ecosystems. And I share this as a joke, but it's very true that the state of Gujarat I come from, people won't really ask you, what are you doing after college? But the first question they'll ask you is, what business are you starting? So this entrepreneurial spirit was sort of sown deeply within me, and I always knew I wanted to start a company. So when I moved to the US to MIT for my graduate studies, I chose a project that not only was scientifically interesting, but also would have an impact on the society. And that's where it all started. In our lab, we developed these materials which are based on hydrogels, again, as the name of the company is, which are these boba bead-like materials that we have decorated and functionalized with various chemistries to enable industrial purification. So we actually started out with water treatment, trying to remove micropollutants like heavy metals and PFAS and other organics from water. Such an important problem, but then by talking to a bunch of customers, we realized that the commercial value of water is much lower than the perceived value, which was unfortunate as the society does not put a lot of value to our water resources. And as a result, to be sustainable, both in terms of longer term growth and growing rapidly as a startup, we pivoted into equally impactful but higher impact and higher margin applications in the food and biopharma industry. And then our team consists of MIT PhD engineers and scientists. So we don't only have a strong technical background, but are all passionate and driven to make a huge difference. And the team is three of us right now. We're hoping to grow and expand our team rapidly in the next year or so. But right now, we are material scientists and chemists by training, who have had experience spinning out companies, successfully exiting them, and also scaling up technologies.
So can you maybe share with us a little bit like your secret sauce? I mean, what makes it so unique? And in you were claiming, at least at the beginning of the conversation, that you make it also cost effective compared to the other alternative in the market. Can you give us a small wrap up there?
Sure. We have our competitive advantage on multiple fronts. One of them, which might seemingly be obvious, is the design and chemistry of these materials. So we took these hydrogel scaffolds, so think of boba beads, but then also functionalize them with specific chemistries that help us remove the impurities in a specific manner while leaving behind the valuable product. So by doing that, you don't only design a bespoke solution for the customer, but also reduce or eliminate the loss of product to your purification step. So chemistry and material design, I would say, would be one area. But we've also made these materials in a way that you can reuse them several number of times. So once these are saturated with impurities, you remove those impurities and make these materials fresh to be reused again. And so far, we have shown that these materials can be reused up to 100 times. And this is in stark contrast to a lot of existing materials that the industries use currently, which is activated carbon and chromatography or ion exchange resins. And a large potential customer we are working with in South Korea, who is a large producer of amino acids, uses over 10,000 tons of activated carbon each year, which is a lot. And they don't reuse any of that. As a result, when our materials can be reused up to or at least 100 times so far, you significantly reduce the waste associated with these materials and the processes, and also extend the lifetime of materials used for purification processes, which not only reduces cost, but also significantly reduces the carbon and the physical footprint associated with your processes. And I would say the third bit, which is not talked about very often is the way you manufacture these materials. Of course, activated carbon is mined. It's carbon, it's charcoal, so that's inherently unsustainable. But also with a lot of resins industries use, these are manufactured using toxic solvents, including toluene or cyclohexane, which we are hoping to eliminate completely in our manufacturing process. As a result, you also have an impact on the manufacturing and how these are used later.
So to close up this little I would say spotlight on your company, can you maybe just tell us a little bit more about like your go-to-market strategy and what are the eventually the opportunities or the bottleneck that you see in terms of like the production of the hydrogel itself?
Sure. So as I briefly mentioned, we are working with a large potential customer, which we are really excited about. They are a South Korean company that already paid us $75,000 to do a proof of concept test. And now we are in discussions with them for a smaller scale pilot next year. And that's just one customer in the food space, but we are already in discussions with other huge amino acid manufacturers around the world. And the other bit that we are hoping to tackle is in the biopharmaceutical space, where there's a huge need given the increasing number of newer modalities that are being developed in the space, as well as helping solve other challenges associated with purification of things like monoclonal antibodies, peptides, or even vectors for gene therapies. So we are in discussions with some partner companies in the space and hoping to do some proof of concepts in the next year or so. As far as manufacturing is concerned, that's definitely a huge question and challenge for startups like us. But we've made good progress in the past couple of months. We've scaled up our manufacturing in the lab from producing 1 gram or 1 to 2 gram of materials per day in the lab to now being able to produce 1 kilogram of the material. So a 3 order of magnitude increase in the manufacturing capacity. This is still not enough to be deployed at scale. And as a result, we are hoping to scale up the manufacturing by 100 times in the next year or so. So being able to produce at 100 kilogram of our material on a daily basis in our facilities. And of course, these need to be tested at scale in these large packed bed columns, ensure that there's no leaching. So there's no impurities we are introducing through our materials. We've done some of those tests so far, but that remains to be seen at scale. And also the ability for these packed bed columns or the equipment to withstand potentially high pressure drops that would be associated with purification of products. And yeah, so we are hoping to de-risk some of these engineering challenges as we start to work with customers, learn from some of the mistakes we might potentially make there, and then loop that in to ensure that the process is smoother.
But thank you so much for sharing all of this incredible journey. Can you tell us maybe a little bit more about like this experience that you just wrapped up now with the Cleantech Open program? Beth mentioned it's a mini MBA, and you also you're fortunate to be also a part of the MIT alumni and network. So, what did you take out of that that batch and that program that you did with the Cleantech Open? What did you learn? What was the initial challenge that thanks to this program you were able to solve? Maybe in a couple of them that you could mention.
Mm-hmm. Yeah. Cleantech Open has been an incredible experience. We've gotten much more than we anticipated going into the program. First of all, we were incredibly fortunate to have a wonderful group of mentors, which the team did a great job of matching us with. They were not only patient and willing to listen to our inputs, but also brought in a lot of wealth of experience through their expertise in many different fields. So we had a very well-rounded team of mentors who helped us really well. So very grateful for that, as well as the other sort of programming and networking opportunities that the program brought along with itself. One of the key challenges going into the program was finding that first killer application. Um, as you would have guessed, our technology is more like a platform, right? We started with water treatment, but now you could also look at purifications in the food and biopharma space. And as a startup, we needed to focus given our limited resources, both people, time, and money, right? So we wanted to go after that first killer application. So the program really helped us hone in on identifying our value proposition, finding a competitive advantage, and then boiling down to a list of the industries that we could think about going into first. And of course, as scientists or people with technical background, we didn't have much experience with defining a financial model or even doing some sort of techno-economic analysis, which we had a back of the envelope estimate coming into the program. But then through Cleantech Open, we developed an extensive financial model, which I think is incredibly important because, as we say, having a good technology is necessary but not a sufficient condition for success. As a result, understanding the customer's needs, putting them first, as well as the value we bring to them, not only in terms of sustainability, but also solving their problems and reduction in the costs associated with these purification challenges was a huge plus for us.
Thank you so much, Arjav. So maybe last question before we start to move on with the others. Can you tell us just like how can the community of investors, founders, experts listening to the show help you, and what's next for Hydrogel?
Absolutely. I'd welcome any support in the form of expertise or partnerships from people who have been in the industry. Like I mentioned, we are first-time founders, so very passionate and driven to take this forward. But then that also means that we haven't scaled up manufacturing or built facilities. So any sort of support or mentorship there would be incredibly valuable. And we are planning to raise a $2 million seed round early next year to scale up our manufacturing and then do a lot of these proof of concept tests with biopharma customers and potential pilots with companies in the food space. As a result, any support there would be incredibly appreciated and valuable as well.
Fantastic. Thank you so much, Arjav. Congrats on everything you already achieved as of today with your team. So definitely let's be in touch. Okay, now we're gonna move with Marissa and Turnover Labs.
Yeah, thanks for having me. So I can give an introduction to myself. My name is Marissa Beatty. I'm the founder and CEO of Turnover Labs. And what we're doing is we're trying to take waste emissions that are coming out of chemicals production and recycle them back into basic chemical building blocks.
That's exciting. So tell us a bit more about it. Like, tell us a bit more. What was the genesis of the of Turnover Labs, and try to understand a little bit more, like your secret sauce, where you're at today. Love to hear more.
Right. So the genesis of Turnover Labs kind of came from two different problems colliding. So I spent a considerable amount of time doing electrochemical research at Michigan State University and Columbia University on how to make electrochemical technologies more durable. Right now, they're extremely sensitive. The comparison that we often make is they're built kind of like Lamborghinis, expensive to drive, expensive to build, and you can only really drive them a couple of days per year. And that's what made it very difficult for electrolysis to break into the industrial sphere and industrial operations, which are not built for Lamborghinis to be driving around. So that was the side of the research that I became very passionate about. And then on the side of what's been happening in the world, there's just been a tremendous drive in the chemicals industry to reduce emissions and to reduce the carbon intensity of different products. This drive can be both opportunity-based because consumers want higher quality, sustainable products, but also from the regulation side of things and the supply chain side of things on the petrochemical side. So chemical producers have been looking for sustainable technologies, but a lot of their facilities are built to last another 20 or 30 years, with, outdated technology that's going to be leaking CO2 this whole time. So there really is a demand to find a way to make their operations more sustainable, but still be able to keep all of those assets that they've invested in. So how do we retrofit these facilities with technologies that can make their process more sustainable and less emitting?
So could you eventually walk us through Turnover Labs? Like maybe you have like one specific example that you guys are working, or a company that you're working with, and from start to finish, in few words, how does it work, and what are the I would say the bottleneck that you face today, and how you're overcoming them?
Right. So the technology that we have is really cool because we built like a very, very durable electrolyzer. You can feed it really impure, contaminated streams of CO2, which has the economic benefit of not requiring tremendous carbon capture or tremendous carbon cleanup, which right now is needed in order to make use of industrial CO2 because it's really, really dirty and contaminated. So we're working with some folks who have some petrochemical refinery operations, and they're emitting CO2 that's actually coming out in kind of a high concentration, but it's coming out alongside a bunch of other stuff too. And it's very energy intensive to remove that extra stuff. But our electrolyzer is right now just being very passive about it. It seems to not be caring about those impurities in there too much. So we can install and go to that facility site. We can install our electrolyzer on that waste emission stream as a slipstream, pull the CO2 selectively out of that stream through our process and convert it into a basic building block, carbon monoxide, which they can then use in other chemical operations. So carbon monoxide right now, they're using it from natural gas, but they could be using it using these waste emissions instead.
Okay, and so if you look at like the I would say like the when you collect this carbon dioxide, like I mean, in which form is like a gas, is like a powder, and how do you easily transfer that to the rest of the facilities to be reused? Is it like challenging, or is it require a lot of manual like intake from your team, or from the local partner team?
Yeah. So the thing that we wanted to emphasize was being small and efficient to deploy on site. So right now, moving CO2 is a very non-straightforward problem. So like even if folks do engage in carbon capture on site, moving massive quantities of CO2 to another site to convert it into chemicals is a major barrier in the sustainable chemicals production space. So the whole idea is that we're pairing out and we're taking away these extra pieces of technologies that make our system too large or too expensive to install on site. So we've eliminated those so that we can go to the facility and essentially just sit on top of the process that would be accepting the products from our technology. So taking CO2 coming out of one stream, they're located very closely in proximity in the plant site to one another, and then essentially just piping it over to the process that needs the carbon monoxide.
And what's the cost of that ton of CO2 or kilo of CO2? I don't know, that you are capturing, because it's always like the bottleneck there. What are the current and expected costs that you guys have been looking at?
Yeah, so since we're using concentrated streams, it's not too expensive. We're electrolysis based, so again, like $400 to $500 per ton of CO2. But the thing is we are also manufacturing a product that does have close to that amount of economic value associated with it. So rather than doing 500 tons of CO2 that we're pulling out of the air and then getting a $200 credit, we're spending $500 to $400 pulling it out of this mixed stream and converting it into something that has an economic value of $550 to $600 per ton of CO2 or per ton of CO that we're manufacturing. So we are technically a profitable process right now before even taking any subsidies or credits.
That's exciting. So it's a little bit like the bottleneck of those climb walks of this world. And at the end of the day, you're producing some added value for the host or the emitter. So it's even better. Can you tell me a bit more about your the current alternatives that are in place, or existing alternatives of Turnover Labs? Who are the competitors, and how do you position yourself there?
Yeah, so there's obviously like this is a super hot space. Everybody's trying to turn CO2 into something. I think that there's a lot of folks doing emphasis on building first-of-a-kind plants, building things that are very standalone, and I think that's absolutely necessary for us to move forward, to build brand new shiny facilities and have fully sustainable pathways from like DAC captured CO2 all the way down to like things like fuels or plastics, et cetera. The way that we kind of differentiate ourselves, like I said, is we're really trying to work with the dirty CO2, kind of the leftover CO2 that a lot of other companies aren't focusing on. It is very deactivating to a lot of chemistries, and it does cause a lot of issues when you try to install separations on that CO2 that just makes it not make economical sense for the chemicals industry. So we are specifically building technologies to deploy within the chemicals industry and use kind of this leftover garbage CO2 that maybe isn't high enough quality for current processes.
And which company or subsector in the chemical industry is your beachhead market so far?
Yeah, fantastic. We're looking actually in the polyurethane space. So this is something that's used in a lot of different industries, whether it's like automotive or high fashion. You might know polyurethane is vegan leather. So there's a lot of opportunity for us to come in and reduce the carbon intensity of things like vegan leather, reduce the carbon intensity of things like polyurethane insulation and foams in construction and automotive. So that's our first beachhead market. And that's something that's Cleantech Open really did help us narrow down on, because we were picking everything from methanol to all the way down to like jet fuel and other basic polymers. And working with the mentors in the Cleantech Open really helped us narrow that focus and determine that there was like downstream draw for that product.
And looking at that beachhead market, that thanks to the Cleantech Open, you guys were able to refine and narrow down. Can you give us a little like market estimate there, and what's the business model that you are looking to put in place or have in place?
Yeah, so I mean, the market size depends on, right now we're just starting at this beachhead market, which is about $45 billion. It's kind of small for the chemicals industry. The number of processes that our technology could slot into amount to about $500 billion in total addressable market. But again, you got to start off with focus, which is something that Beth and my mentors have constantly drilled into me. And then what was the second part of your question? I apologize.
No, I mean the second part of the question was to try to understand so the size of the market, and then looking at like what is the current business model that you guys are looking to. I mean, are developing? Did you put in place? Are you getting some initial like paid proof of concept project? Tell us a bit more about like how you gonna make money at the end of the day.
Yeah, so we have a couple of collaborations, some paid collaborations that'll be teeing off in 2025 that are in negotiation right now. So that's pretty exciting. The model that we want to follow, we have new technology, so we can't really change too much. This is the chemicals industry. They really don't like changing the book too frequently. So we were going to follow models that these customers were already really familiar with. And that's either equipment leasing or it's going to be contractual supply of these chemicals. So that carbon monoxide stream, you can provide that via contracts. That's how they're currently buying it right now from other carbon monoxide providers. That being said, we're currently trying to figure that out right now about which direction yields more in the market that we've currently started exploring as our beachhead. So ask me in like 3 months and I'll have a lot more of a concrete answer for you.
No, but that's fantastic and very exciting. So maybe you can, I mean, and you mentioned one of the example already about your experience with the Cleantech Open. Maybe if you have like one or two other extra, additional challenges, and as a founder early stage, you probably had like hundreds of them that you had to tackle and go over. That's in a way specifically the Cleantech Open, and your experience with the Cleantech Open was a positive one. Maybe there's also stuff that they can improve. Huh? I think it's on both sides.
I don't know if I'd go that far on this podcast, but I will say that the thing that I got very much out of the Cleantech Open was just access to these mentors who have spent a lot of time working, not just with entrepreneurs, but in the chemicals industry. So like 20, 30 years working in these contexts that we're trying to go into. And they have a very sobering and unforgiving set of insights that they can provide early stage entrepreneurs. I think Arjav mentioned that it's very, as academics, you don't necessarily get to see that side of things too frequently. And it is very nice to like come up with your like bright and bubbly ideas about sustainability and kind of get that weathered down by people who have seen this song and dance a number of times before and say, listen, this is going to work, or like this isn't going to work, or you really need to have this number down if you're in these conversations. So the very direct and intense level of feedback that we got every single week for like an hour and a half really helped us whittle down on things that were maybe out of reach right now, and find something that is a little bit more practical and feasible in the short term to get us off the ground.
So what's next for Turnover Labs? I mean, tell us a bit more like how the community of investors, founders, experts listening to the show can help you out, guys, and what's next for the next 6 to 12 months, which is a long term already for startup life.
Exactly. Yeah. So we just closed a round of funding, which is a really nice position to be in as a startup. And we've been really working on expanding our team and scaling up our tech. The thing that I like to tell people is that we're just going to break our system a bunch over the next year. So what we're intending on doing, and what we have some stuff coming in for right now, is we're taking emissions from existing chemical processes and we're putting them into our electrolyzer just to see how it fails. And we're seeing how it fails over and over again and building it back stronger so that it can thrive in the field. The ambition behind this is finding areas where we are really, really strong and areas where we aren't, which is important to know too. To find a pilot or a demonstration site that we can install our technology, bring our technology to in the next year or so. So all of this is in service of just identification of that like real world use case and expansion of the team. And I think ways that people listening to this could help is if you know anybody with a chemical plant. I know everybody has friends who are in the chemicals industry like I do, but if you do, we would love to get any sort of data or information about emissions or like emissions reduction that particular facility or that particular industry is doing. Doesn't have to be limited to like hardcore petrochemicals. It can be anything across the board. So if you know anybody working in that industry, we're looking for introductions and we're looking to just sort of learn a little bit more about people's needs.
Fantastic. Thank you so much, Marissa. Very exciting, all of the progress and what you guys are doing with Turnover Labs. So definitely keen to follow you guys and learn more about what you do. Okay, now we're gonna move with Jeff. Jeff Greenspear.
Yeah, so my name is Jeff Maelstrom. I'm the founder and CEO of Greenspear. And yeah, really excited to share with you today a little bit about how we're working to lower the carbon footprint of the battery industry. So we're doing this by making essentially cleaner graphite, which is the unsung critical mineral that goes into these lithium-ion batteries. That's in everything from the laptop or the phone you're watching this on to the EV that's on the road today. So we do this. We have a proprietary catalytic process where we're converting CO2 that we're either purchasing or partnering with a capture organization and converting that directly into a solid state of graphite that can go into all of these batteries that you know and love.
Fantastic. That sounds very exciting. So tell us a bit more, like maybe the genesis of it, like why you, Jeff, was the guy who wanted to tackle that problem, and how did you meet your other co-founders and the rest of your team? Tell us a bit more about like this start of the company.
Yeah, so I'm a mechanical engineer by degree, but I've done work across pretty much every vertical of engineering that is there. Started my career in the defense industry where I learned all about the wonders of red tape and slow-moving big corporate processes before kind of jumping ship to the more agile startup realm. And I really found that I love these very challenging processes to, solve a hard technical problem. But then it's the fact that it's doing good in the world that gets me out of bed in the morning. So really kind of zeroing in on, a challenging problem of how can we source this graphite material somewhere in the US and not have to import it all and do it in a way that's much cleaner and better for the environment. And at the same time, of course, have a company that grows and does well financially is always a plus. So on the team, I mean, we have both the scientist side with PhDs and master's degrees, as well as the engineering side, who has the skill set of building up these industrial facilities and industrial tech to really lock in these processes in ways that scale and is financially feasible, as well as being cutting edge and doing interesting things with with new uses of waste streams.
So can you tell us a bit more maybe about the, I would say, the end-to-end process of Arculus solution? I mean, like, how does it work? Let's take a concrete like case. I mean, are you guys already deployed in one test site, or are you still in the lab? And if not, like, how does it work? How do you see how intrusive it is, or where are the bottleneck in a way, and the opportunity that you already see in terms of like your own process. Love to learn more about that and have the audience who is listening to you to understand that step-by-step process and in a way your secret sauce.
Yeah. So here at Greenspear, we're really working to, find a use for this waste stream of CO2. So we use a liquid metal catalyst where we're essentially running this reactor at, I call it low temperature, 400 to 500 degrees Celsius, so about the same temperature as a pizza oven, and introducing this CO2 gas into that liquid phase in our reactor. And basically what happens is that metal is preferentially oxidized, so basically stripping that oxygen molecule off of that CO2, which forms a nice little graphite crystal at the bottom of our liquid phase. And as it rises and continues to react, that crystal grows into a nice little graphite shard, which can then be purified and made ready for the batteries. So right now we're operating at kind of the lab scale. We make about 5 grams of material per day, which doesn't sound like much, but it's about a 10,000x scale up from the rate we started at. So definitely a firm understanding with our team of how to make this process do what we want it to. And so we're currently in the phase of finding customers for kind of these small sample orders, getting a lot more test results to really build up our kind of credentials within the space as a supplier to these battery industries. They're much more used to dealing with billion-dollar mining organizations or huge chemical conglomerates. So it's kind of an uphill battle for us to really prove that this tech has legs and that this will be a solid way to onshore this production to the U.S. But I think we're on a good line of sight to make that proof point that here's a material that fits all your needs, it's consistent, and it has the quality you need, and we can make it right here in the U.S. and make it in big enough quantities to fill the supply gaps as people want more and more batteries.
So can you tell me, I mean, you mentioned like 5 grams daily as a production. It's already 10,000 times you mentioned, I think, better than when you guys started. But to give us a perspective, like in terms of like what is the quantity that you hope to reach at scale, and what would be the cost parity point compared to those imported mined graphite that we can find today?
Yeah, so our MVP, or the minimum viable plant, as I call it, is about 1,000 tons per year, is where we can start making a profitable company. But I think the real scale we want to get to is about 20,000 tons per year, which that's more the standard kind of synthetic graphite plant that operates today. So we think at that scale, we can get our cost well below the current methods of making that synthetic graphite. And that's really due to the fact that the technology for making synthetic graphite hasn't changed in the 100 years since it was discovered. It really just involves, burning out already mined coke coal and processes or materials at a very high temperature for about a week. So it's a really cost-intensive and carbon-intensive process, whereas we can be making that material a lot faster and with a lot less energy. So we see ourselves as being really happily in that spot where we can have a good profit margin and still be undercutting the competition at scale.
That's exciting. So speaking about the competition, I've seen other companies also in the space utilizing like CO2 to produce synthetic graphite, and also having the ambition, as you mentioned, to put that back on the US soil and creating this independency, geopolitical independency that's probably going to be even more needed as of the election of today. But tell us a bit more, like, how do you guys see yourself, and is there space for many of you there, or is more like one market one winner, I would say take it all. How do you compare to yourself to others? You don't need to name anyone. I don't think it's the purpose to stab anyone in the back here, but tell us a bit more about you guys and how you see yourself as the next winner.
Yeah, so I mean, it's an absolutely massive market in terms of tonnage of material. In the US alone, just for EVs, so not looking at grid storage, not looking at consumer goods, batteries, we use about 300,000 tons of graphite per year. So there's a massive opportunity for several startups to win and be profitable in this. And also, most of these kind of battery manufacturers like to have a diversified supply. They want to make sure that no matter what, they have that material coming through the door and that they don't ever have to shut down their production. So it's understandable that they would want to retain several different sources of material. But I think the thing that really sets us apart from some of the other startups in this space is just how quickly we think that we can scale this process. So we're taking a known reactor technology and adding some, special tweaks and some, special sauce to it to make it do what we want. But we're not reinventing the wheel fully with how we're doing this process. And I think that really lends itself to, while this would be a first of a kind plant, it's not entirely first of a kind systems. And really just lets us hit that gas pedal really, really hard to get up to scale very quickly. And I think that's going to be a big differentiator for us to break into this market, as that, supply is not able to meet demand as people want more batteries and more energy storage.
Mm-hmm. That makes sense. In terms of like IP and I would say protection, like how do you protect your technology? I mean, how replicable it is by others, by people who would like to go faster. Do you see yourself like well protected, or you really need to go into this market race now as fast as possible to capture a piece of this large market, as you mentioned?
Yeah, so we're actually doing both. So we have 3 patent pending technologies right now, and we have a lineup of several more that are going to get put into that portfolio, both around our process, the systems we're using, the control systems, as well as the real like secret sauce in our alloy that make this a scalable and cost-effective process. But at the same time, there is always that first mover advantage of being the first company to come in and have that, greener alternative without a green premium. I think puts us in a really nice spot to where it wouldn't be worth it for someone else to try and, replicate us. It'll be, they might as well just buy us at that point, which would be a nice little a win for everybody. But yes, I mean, it's no one strategy. It's making sure we're covering all of our bases and making sure that we're ready for whatever comes at us.
So ultimately, like, what's your go-to-market strategy?
Yeah, so we've identified a couple essentially stepping stone markets within the battery space. Starting with some lower volume, higher value customers who, order on the scale of, a few hundred tons per year of graphite material. And therefore, are willing to pay a slightly higher price per kilo or per ton, before kind of stepping up to, the mid-scale manufacturers who are more in like grid storage for, battery banks for wind or solar plants, before jumping up to, the big guns at the end of the EV market, of really looking to be in that supply chain, particularly in the US at this point, to take advantage of the IRA and the bipartisan infrastructure bill, and those incentives that are there currently. But beyond that, there's no reason we can't start to export this technology worldwide to, take part in cell phone manufacturing, in global EV manufacturing. But I think it's really important for us to have those stepping stones identified where we've scaled our production to meet that market need at that segment and have that, cost appropriate material available.
So I understand in terms of like the customer acquisition, I mean, your customers targeting itself, but in terms of like supplying this the CO2 necessary for your process, I mean, who are the initial like industries that you guys are looking to work with, and where are they geographically speaking spread out around the US or in the world? Because I guess like you're depending of the source. So tell us a bit more about that.
Yeah, so we're in talks with several different, point source or DAC companies to be potential suppliers. But at this point, we're just purchasing our gas off the open market. So pretty much industrial and medical CO2 is all coming from fertilizer production. So it's called the Haber-Bosch process. It makes modern farming possible, but it also makes a lot of CO2. But I think in the long term, we would love to partner with a DAC company, but the technology is just not really mature enough at scale to provide the amount of CO2 that we're going to need. So realistically, we're looking at more of a point source capture type deal. And for example, in the US, there's a coal-fired power plant in Texas. I believe it's called Petronova, where they're capturing almost 5,000 tons of CO2 per day, and currently just injecting it into the ground for storage and sequestration. And so for us to, end up as a partner with a site like that, where we can add value to that waste stream well beyond, the $100 or $200 for a carbon credit, I think is a win-win for everybody. So that's kind of our pathway to hit that scale.
Fantastic. And how was your experience with the Cleantech Open? What was the few key pieces of or gold nuggets that you captured along the way during that experience, and that were probably the initial challenges that you guys were facing?
Yeah, so as the other folks have said, it's really the mentors are a huge resource within the program. They very much have helped me temper my engineering and project management background of wanting to underpromise and overdeliver, and really being a little bit more on that greed side for the investors and the customers of, no, you want to get in on this rocket ship as it's taken off. But yeah, so just the access to that expertise in an environment where they're there to help you and they want to see you succeed is invaluable. And you just can't get that in many other programs.
So what's next for you guys? I mean, how can the community of investors, founders, and experts listening to the show can help you? Tell us.
Yeah, so right now we're in competition for a couple different grants, and we're currently raising our pre-seed round to really scale this technology to get up from making a couple grams a day to making a couple kilograms a day. Basically would allow us to make it rain graphite around the country for everyone that wants to test our material can get it. But the big thing we're always looking for is to talk to more customers. So anyone that's manufacturing battery anodes or batteries themselves, we're happy to talk to you and learn a bit more about your process and what your needs are and how we can best meet those needs. It's definitely would be a great help to us.
Fantastic. Thank you so much, Jeff. Congratulations on all the amazing progress that you guys are doing and this incredible journey that you're on so far. So. Hi, Gianluca. Welcome to the Tech for Climate podcast. You were not there during the first session that I did with the other participant of the Cleantech Open, so I'm super happy that today, new screen, new decor, new clothing on my side to welcome you. So we're gonna also cover your company today. Pretty excited. Could you please give us a 30-second introduction about Arukulus solution?
Absolutely. So nice to meet you all. I'm Gianluca Roscioli, CEO and founder of Arculus, and our mission is to retrofit natural gas transmission pipelines to transport new forms of energy. These can be hydrogen, both pure or blended with natural gas, CO2, or even just natural gas by extending pipelines' lifetime.
So why can you maybe tell and reframe a little bit like the situation on your side for the audience? I mean, why did you start Arakulus solution? Who is this solution for? I mean, how did you identify that unique problem? And if you can maybe give us a little bit of overview of the current market and the pain that you are solving there.
Absolutely. So the company started at MIT. It was a joint research project between three different groups. Chanta Shan, that was my PhD advisor, Julie, and Bill Gales. And it was funded by Exelon. They wanted to find a solution that could retrofit natural gas pipelines to accommodate hydrogen blending. And that's where the multi-layer aluminum oxide layer coating was born. At Arculus, we want to bring this solution to market. So we licensed the patent from MIT, and we developed in-house a robot that can travel inside 12-inch diameter pipelines to apply the coating on the internal surface. This coating acts as a barrier to hydrogen permeation so that it avoids all the issues connected to hydrogen. Because hydrogen cannot reach the steel, it is impossible to embrittle it, and so we avoid all the potential catastrophic failures associated with hydrogen.
So can you tell me a bit more about like where you're at in terms of development, in terms of commercialization?
Sure. In terms of commercialization, we are going to partner with pipe cleaning companies. And this is a discovery that we actually did during the Cleantech Open program, because originally we wanted to go to market ourselves. But through primary market research, we found out that entering the oil and gas business as a startup is almost close to impossible. This is because you need to negotiate master service agreements with the utility companies or pipe owner companies, and those can take easily 18 months. So our strategy changed, and it became partnering with pipe cleaning companies that already provide a service for the utilities or pipe owner companies. And we simply go after they clean the pipes. So we partner so that they run their pigs, that are the name given to the robots that go inside pipelines to clean these pipes. And after running their pigs, they also run our smart pig that we call Spatter Pig. And this robot simply travels autonomously inside the pipelines to apply the hydrogen barrier coating.
Okay, and so it means that therefore when you put this hydrogen coating on it, it's like there is a complete repurpose of the use of the pipeline. We're not talking about oil and natural gas anymore. We're just talking about like hydrogen and other gas that you think that you were mentioning before.
Yes, but not completely. So the coating is, so if we look, for instance, at hydrogen, the coating is perfectly compatible with both natural gas and hydrogen. So we realize that the switch from natural gas to hydrogen is not an on-off, but it's going to be a gradual blending of more and more hydrogen to go towards a full decarbonization. The issue is that appliances, for instance, can only withstand 20% hydrogen blending, and gas turbines can only withstand usually up to 60 to 70% hydrogen blending. So as you can see, there needs to be other developments. The more hydrogen you add to the line, to be able to become feasible to go towards full decarbonization and full 100% hydrogen. So this is what we do with the coating. It's one simple solution that allows you to blend any percentage of hydrogen inside your gas stream. So after you apply the coating, you can still use the natural gas pipeline to transport natural gas. It's actually impervious to corrosion, so you are extending the lifetime of these pipelines. But utilities or pipe owners can also start blending more and more hydrogen inside their pipelines as much as they want, up to 100%.
Okay, and can you quickly tell us a bit more about like the current situation? I mean, how do you see like this evolution happening with like increasing this blending? I mean, oil and gas company are really in the lookout of like changing now their blend towards like full hydrogen, or is really something gradual? Like, what is the timeline that we're talking about?
So for hydrogen, we are talking about a timeline that is going to be towards 2028 to 2030. And that's the reason why our beachhead market is actually going to be CO2 pipelines. The coating can enable retrofitting for both hydrogen and CO2 is a more immediate need. This is because of direct air capture or other technologies like steam methane reforming to capture the CO2 from natural gas cracking. And there is the need, after you capture this CO2, to transport it towards storage units For instance, in Louisiana, these are used up oil wells that are already classified to be class 6, so available for CO2 storage. But there is the need of the pipelines that goes from the capture point up to the storage unit. And that's where we can help. We can, in most of those used up oil wells in East Texas and Louisiana, there are already the pipes available because they're the ones that were used to extract the crude. And we can simply retrofit those pipelines so that we can allow for CO2 transportation.
Last question on my side. Can you tell us a bit more about the technico-economic aspect of Arculus solution? I mean, how much does it cost to produce this special coating, and what is the potential business model and margin that you guys are looking at there?
Absolutely. So it took us about, at MIT, it took about 6 years to develop the coating. And internally at Arculus, 2 years to develop the robot that can travel inside pipelines to apply the coating. And the business model changes geographically. So in the US, Canada, and Europe, and also Saudi Arabia, we want to charge a fee per mile or a fee per kilometer of coating applied. This depends on the diameter of the pipe. So if you are looking at 12-inch or 30-centimeter diameter pipes, the cost is going to be $30 per foot or approximately $100 per meter. And this includes cleaning of the pipe carried out by the partner, as well as coating of the pipe carried out by us together with the cleaning partner. For the rest of the world, instead, we are looking at licensing fees. So we'll lease our technology, our robot, and ship it worldwide to other cleaning companies that want to deploy this technology, and simply get a licensing fee from them after they apply the coating and after they carry out their business.
And the size of that market specifically, I mean, you mentioned the beachhead market with CO2, you mentioned hydrogen, you mentioned the blend. I would say for your specific coating and utilization of this incredible robot that you guys developed, can you give us a little bit of order of magnitude that we're talking about?
Absolutely. So if you look at just the natural gas transmission pipeline market, it's already gigantic. We have over 320,000 miles in the United States, plenty more worldwide, for a total of 944,000 miles globally. If we just manage to coat 35% of these pipes, we have the opportunity to make $30 billion. We want to start from the US, so our SOM is a little bit smaller, just a little bit shy of $10 billion. If we manage to coat 35% of those pipes, and the actual beachhead market is even smaller because it's related to CO2 pipelines, and we assessed it to be about $480 million.
Any major?
Sorry, Guilherme. I also want to add that later on, after pipelines, we want to expand to other industries. This is because hydrogen embrittlement is not a problem just confined onto pipelines, but is also affecting automotive, aviation, and nuclear. So later down the road, we will see how to implement our coating also for those other applications.
Last question on my side before you're going to share with us a little bit your experience with the Cleantech Open. Any major competitors popping out in that market? I mean, how defensible are you guys?
Absolutely. There are two different technologies. The first one is pipe-in-pipe solutions, and the second one is full replacement. Unfortunately, while pipe-in-pipe solutions are being used for different applications like water pipe fixing of leaks or drainage pipes, they are not really safe for hydrogen. This is because when you place a plastic pipe that is usually high-density polyethylene inside the steel pipe, you can have preferential permeation of hydrogen through the plastic pipe to reach the steel pipe and start embrittling. So you have this quite large capex expense to install these plastic pipes inside the steel pipes, and then 1 year or 2 years down the road, you have your asset completely destroyed and damaged by hydrogen, and so you need to replace the entirety of the asset. Full replacement, on the other hand, is the one that is highly expensive, and this is also not environment friendly. It involves manufacturing of new pipelines made out of stainless steel, and also dismantling of the old pipes. And these processes are both CO2 highly intensive. In addition, there is also the issue of permitting time and installation times of these new pipelines, because we built the grid that we have today over decades, not just over days or a couple of years. So it will take time to build an entire new infrastructure. Our coating can be available just already as of summer next year.
Fantastic. Can you tell us a bit more about like your experience with the Cleantech Open? I mean, what was the initial challenges that you were facing before starting the program? What did you learn during that program? Maybe if you have like one or two key takeaways that you want to share with us.
Absolutely. So during the past 6 months, I told you, our original idea was a little bit brave and naive, I would say, where I wanted to go to market ourselves, conquer everything, and make tons of money in doing that. Quickly realized through primary market research that this would have been nearly impossible. And that's why it's not really a pivot, but we changed our go-to-market strategy, and we started thinking about partnering with other companies that are already in the sector, like pipe cleaning companies or inspection companies, and get help from them without disrupting their business model. So we managed to enter a letter of intent with one company in Lafayette, Louisiana, and then that led to the Design to Solutions. That led to another letter of intent, which is Hunter, and now we are discussing a joint development agreement with both of them, and we are also discussing a letter of intent with Saipem, that is a pipe installation company in Europe. So our business model changed during the program because we moved from going to market ourselves, which would have been time consuming, although we could have got higher margins, to partnering with other companies so that they can help us get to market faster, although they will get a percentage on the revenue.
Fantastic. Thank you so much. So what's next for Arculus Solution?
Absolutely. We are currently raising a 5 million seed round, and that's in order to finalize our minimum viable product, carry out pilot tests in-house in our mechatronics laboratories in Newark and New Jersey at Axe Laboratories, and then carry out a field test together with N2 Solutions in their facilities in Lafayette, Louisiana. After that, we will start going towards commercialization, so deployment and commercialization of the technology for CO2 pipelines, while we will still be carrying out tests with Southwest Research Institute and Louisiana State University in order to classify the coating to be compatible for hydrogen pipelines so that we can start enabling that second market as soon as we get all the classifications.
Fantastic. Thank you so much for coming on the show, and congratulations on being one of the finalists of this incredible adventure with the Cleantech Open. But I think we got everyone for today, no? If Beth is still there, I don't know if she left.
Nice. Thank you very much. Yeah.
Fantastic. How was it, Beth? Besides my background, I was not there.
It's fine. I think the entrepreneurs are very very clear about what they're working on and what the value is, and that's really, and it's really great to hear them praise our program. But it was nice. Thank you for putting it all together.
But thank you so much, Beth, and everyone who came today. It was fantastic to hear your stories and all the amazing initiatives and companies that you guys are building.
Great.
So hopefully people in the audience will be able to reach out and help them, and we'll definitely be happy to keep following up with you guys and see how we can support you
Yes.
in the future with fundraising and exposure. Thank you so much.
Yeah, there's actually one other thing which I didn't get to share, and I'm wondering if I could just add it now, which is that
Yes.
we are running a direct air capture accelerator this fall. And that's been a really great experience. It's an opportunity for us to work with that next frontier of startups in this space. And hopefully we will be able to take the learnings from that and make our program even better. And if we're able to find some support, financial support, we will continue it again next year. But it's been supported by a prize from the DOE this year. So we'll see if we can do it again, but it's a wonderful opportunity to be able to do this. And so another thing that we're working on, and we're having our finale on December 10th at Greentown Labs in Boston. So happy to
Fantastic.
talk to anyone who's interested in that as well.
But thank you so much, Beth. It was a pleasure.
Thanks again for joining us on the Tech for Climate podcast. I hope you enjoyed the show. Stay tuned next week for more climate tech insights. In the meantime, head on over to our webpage at startupbasecamp.org, where we have lots more insights and resources for anyone wanting to get involved in climate tech. If you find our resources useful, please consider donating to support our small self-funded team. Don't forget to subscribe and share with your friends. And see you next time.